Hello everybody, welcome to the video. Today we're going to be going over how to graph the general form of parabolas, and the equation looks like this. Notice that you have an x squared term, you have a y term, you have an x term, and you have a constant. There's no y squared term. If there was a y squared term, it would be a circle or an ellipse. And also notice that a and b cannot be equal to 0, because if that's the case, it would just be a straight line. So the strategy today is to get it from general form to vertex form, because once it's in vertex form, we can figure out what the vertex of the parabola is, which is either that minimum or maximum point, and then we can just plug in numbers to figure out what the parabola looks like. So what I'd like to do today is I'd like to review how to graph the parabolas when it's in that vertex form, and then I'd also like to go over the algebra for getting the equation from general to vertex form. So let's begin with that review. This is what vertex form looks like. You got y equals a times x minus h squared plus k. So the coordinates h comma k are going to be the vertex of the parabola, and a is just a number that kind of determines how wide or skinny the parabola is. X and y are of course going to remain as variables. So let's consider this example right here. So this equation is in general form, and so the first thing, in vertex form, not general form. And so what we have to do is figure out what the vertex of the parabola is first. So the vertex of the parabola is at 2, negative 5. The reason why it's at 2 is because the equation says minus h, so you take the opposite of what you see here, the opposite of negative 2, which is positive 2. And then the y-coordinate of the vertex is going to be whatever this number is, negative 5. So 2, negative 5 is the vertex of the parabola. So we can go ahead and graph that point. Then remember that for parabolas, you need 5 points to graph the parabolas. So what we do is we make a table like this, putting the vertex in the middle, putting 2, negative 5 in the middle. And then what we do for the other x values is that we just include consecutive x values. So the two numbers before 2 would be 1 and 0, and the two numbers after 2 would be 3 and 4, okay? To determine what the y values are, all you have to do is plug in. So let's plug in 3 and 4 into the equation to get your y values. So we plug in 3 in red right here. We plug in 4 in red right here, as you can see. And then you do PEMDAS to figure out what the value is. So you do the parentheses first, then exponent, then multiply, then subtract. So when you plug in 3, you should get negative 2. And when you plug in 4, you should get 7. Technically, you could also plug in 0 and 1 into the equation, but you should know that parabolas are symmetrical, so that means that these two y values are always going to be the same as these two y values, as long as the vertex is in the middle, okay? So I can just include those numbers. So negative 2 would be right here, and this 7 right here would be right there. So what we have here are our 5 coordinate points. We have 0, 7, 1, negative 2, 2, negative 5, 3, negative 2, and 4, 7, okay? So we can plot those points right there, and then connect them with a smooth curve to make our parabola. Okay guys, so with that review out of the way, let's take a look at this example right here. We're asked to graph this parabola, so at negative x squared plus 2x plus y plus 5 equals 0. So we're going to basically have to get this in vertex form. So the first step for doing that is that we have to get everything except the y term on the other side of the equation. Remember, we're trying to get the equation in this form. Y equals a times x minus h squared plus k. So y is all by itself here, and everything else is on the right-hand side. Okay, so that's the first step. We just have to get everything except for that y term on this side of the equation. So we add our x squared to both sides, we subtract 2x from both sides, we subtract 5 from both sides. And the equation looks like this. Y equals x squared minus 2x minus 5. Then our next step is that we have to complete the square with the first two terms on the right-hand side, factor and simplify, okay? So let's complete the square. So here the middle term is negative 2x, so the middle coefficient is negative 2. We take that negative 2, we divide it by 2, and we square it to get positive 1. So we add 1 to complete the trinomial, and we could also add 1 to this side of the equation, but remember we just want y here. So rather than do that, we're going to actually subtract 1 from the same side of the equation, okay? We added this red one right here, and then we're going to subtract it right here, okay? So once we do that, we're going to factor this trinomial, the x squared minus 2x plus 1, okay? And that actually factors into x minus 1 squared, that trinomial in blue. And these two numbers right here, you have negative 5 minus 1, which gives you negative 6. So that's the equation in vertex form. Once we get it into vertex form, we're just going to graph the parabola, and so we can see what it looks like. Okay, so I'm going to take that equation that I got doing algebra, and I'm going to put it up here. So we have y equals x minus 1, quantity squared, minus 6. So the vertex is going to be at the opposite of negative 1, which is at 1, and then at negative 6 right here. That's where our vertex is, at 1, negative 6. So we can plot that point. Then we can have our table right here. Notice that the vertex is in the middle at 1, negative 6. And here we have our consecutive values, okay? So we can either plug in 0, negative 1, or 2 and 3. I'm going to plug in 2 and 3 into the equation right here, okay? So we have 2 minus 1 squared minus 6. So we can do PEMDAS, parentheses, exponent, and then subtract. So those values are going to be at negative 5 and negative 2, okay? Once again, we're going to use symmetry. So negative 5 should be right here, and negative 2 should be right here. So we're going to put those values in right there. And then once we have all those values, we can plot those coordinate points on the graph. 1, negative 2, 0, negative 5, 1, negative 6, 2, negative 5, and 3, negative 2. All those coordinate points are drawn right here. And then we can connect it with a smooth curve like that to make our parabola. So that's how to graph the parabola in general form.